Hello learners, and welcome to chapter 2, where we're looking at, again, more terminology on the human body, but how to read the map, as they call it. With this chapter, there is a lot of words again. So instead of memorizing them, try to break them down. And from last unit, you should be getting better at looking at your word parts. Good. What we're going to look today is at body positions. Now, when it comes to body positions, there's something called the anatomical position. Now, the anatomical position is like this guy here, and it's feet together on the floor, and your palms are out. The reason why there's this anatomical position is that this way nothing is crossing over. If you were to rotate your hands underwards, so your wrist bone, your lower arm bones would rotate over each other if you would turn your palms down. So this is called the anatomical position. Then there's the supine position, which is on your back, or I just remember it as a way to carry soup. And then the prone position, you're on your stomach. Okay? When we look at body planes are imaginary lines drawn through your body, and there's also directional terms. I will do a little, I'm going to do a little presentation, so there'll be another video on body planes to give you an idea of it. And directional terms have to do with body planes, but they're also a way for biologists and scientists just to sound very technical. Okay? So you can have a transverse plane, and a transverse plane separates the top from the bottom. Superior means towards the head, inferior means below. So if you have a superior vena cava, that's the vein that comes from the top of the head, and inferior vena cava is the one that comes from the bottom of the body. Okay, so here's an example of a transverse plane. It cuts you through this way, and you get what's called a cross section. Then there's a medial or a sagittal plane. The sagittal plane separates left and right. So you have medial, and medial is a term that means middle. So your medial, and they're relative. So medial is closer to the middle, lateral is closer to the outside. And a good example of this is your ankle bone. Your inside ankle bone is your medial malleolus, and your outside is your lateral malleolus. So again, they're more related to each other and directional. So here you have a sagittal term, and it gives you a longitudinal slice. Then there is the frontal or coronal. This is usually just done with mainly with when you're looking at your guts or you're looking at your brain. And this divides the ventral from the dorsal. Now with humans, since we stand upright, our ventral is also sometimes confused with the anterior, but ventral is more towards the front of the body, and dorsal is more towards the back of the body. So if you think of the dorsal fin on the shark, that's the big one on the back. So that might help you memorize dorsal from ventral. It'll cut you this way. It's a good way to get a clear look at the guts. Okay. Then there's terms proximal and distal. These are again a relative. Proximal means sort of like approximately or close. So it is the point closest to the origin, and distal is distant. So if you were to look at your arm, relative to my shoulder is proximal to my midline, and the hand is distal or farther away. But if you were considering other parts, the elbow could be proximal, but the elbow will be distal to the shoulder. So it's proximal to your hand and distal to your shoulder. So it's one of those relative parts. We'll talk about more, use the term proximal and distal when we look at the kidneys, because you got a proximal convoluted tubule and a distal convoluted tubule. Okay, so here is an example. Make sure you know these directions. Then there's also superficial, which means up or deep. Sorry, superficial means on the top. So if you're a superficial person, you're kind of flighty and on the top. And deep means towards the inside or away from the surface. So if you have deep thrombosis, that means you've got a clot deep inside the body. Then you have central, which is in the main part, and peripheral, which has to do on your limbs. Here is some definitions to give you, or a summary to give you all the definitions. These ones I want you to know because they will they'll be used a lot. Okay. Now, when we look at body cavities, I have another little video that I'll attach about body cavities. Again, this has a lot to do with, once you know your directions, you can get your body cavity. So you've got dorsal is on the back, anterior is on the front, cranial is by the brain, spine is where the spine is. Anyway, watch the other video because it's got nice comics to describe it all. Okay. When we look at ways and technology in order to look at the body, there's usually a good or a bad to most technologies or why you use it. One of the main ones, especially if you have a bone issue, is an x-ray. The thing with an x-ray is it uses high energy radiation. So an x-ray and a mammogram use high energy radiation. These are very good. They give you a two-dimensional image, but they need to have something dense, very dense. So what happens is the bone will absorb the x-rays because it's more dense and leave a white spot on the x-ray. Then if it's less dense, it will go clear through and you'll have a dark spot. X-rays are kind of they're easy to do. They're very clear to use, relatively inexpensive. There's a lot of x-ray clinics around. But the problem with the x-rays is you must have a dense material. So quite often, if you're looking at the gut, you have to swallow a barium or something that'll absorb it. So not always efficient with softer tissue. Good. Here is, this looks like my knee. I have had a knee replacement about a year, almost 2 years ago now. So this will show you how you've got your bones, which are more dense, so they will absorb the radioactivity, and the metal, very dense, or the metal or the silicone, whatever is used here, will absorb it. And then the tissue, the muscle tissue, is less dense, so it absorbs less of the tissue. Good. And here you have the hip socket showing you the same. Then there's something called a CT scan, computerized topography. CT is a little more expensive, but it's lovely because it slices the body and it will look at softer tissue, which is good to go in. So here's a CT scan. It gives an x-ray. Then you have MRI. Uses very high level of magnetic energy. Again, it is good, but it's not good for anyone's claustrophobic because you go in a little hole. And if you have any metal components, such as a pacemaker or artificial hip, it doesn't work. Okay. Ultrasound is sort of the cheap and easy. This is very good. It uses sound waves, and then the sound waves look at the imaging. Very good for fetal development, very good for looking at heart valves, also very good for an initial scan of your gut. Okay, so here's an ultrasound. Oh, here's the spleen and the kidney. You got to be trained at all these different blobs, but with time, you understand it. And that is the end of chapter 2.